As we finish off this unit, I just want to finish with just a little bit about acids and bases. We've talked about acids and bases in the first half of chemistry, and a little bit when we've started, naming and doing some formula writing. So we know that in the past, acids have always contained a hydrogen, and bases have always contained a hydroxide ion. But there are several different scientific theories or ideas behind acids and bases. So we're just going to take a look at acids and bases in general, and take a look at the two main ideas that we're going to use with acids and bases. If you do any more advanced chemistry, you'll learn more. So first of all, acids are what give food a tart or sour taste, like vinegar is acetic acid, lemons have citric acid in them. If they're dissolved in water, they can conduct electricity. And if we use an acid-base indicator, like a pH strip or something like that, it will change color on an acid-base indicator. Now, for as far as bases, just a little bit about them. They normally have a bitter taste, and most of them are very hazardous, like soap. You wouldn't want to eat soap. They feel slippery. They also will change color if you have an acid-base indicator, and they'll also, if they're dissolved in water, they'll conduct electricity just like acids will. Now, the acid and base definition that we're familiar with is the Arrhenius, acid and base. This is from a Swedish chemist, and he said that anything that contains a hydrogen and dissolves to form H+ ions was an acid, and bases are going to contain hydroxide, and they dissolve, they'll form hydroxide ions. So for instance, we know HCl, hydrochloric acid. If we put it in water, we end up getting H+ ions, and so by his definition that makes it an acid. And we also, for a base example, we could have potassium hydroxide. We get OH- when it dissolves in water, so that would be a base. So this is the definition that we have currently been using about acids and bases. But we're going to add one more here to the mix, and this is called the Bronsted-Lowry acid-base definition. And there are other chemicals that fit the properties that I mentioned as far as the taste, turning an indicator a different color, being able to conduct electricity, that are true for chemicals but don't fit the acid-base definition that the Arrhenius definition says. So Bronsted and Lowry are two scientists that worked together, and they proposed a slightly different take on acids and bases. They said that anything that donates a hydrogen ion is going to be an acid, and anything that accepts a hydrogen is going to be a base. So if you take a look at this equation, I want you to notice that NH3 is picking up a hydrogen because it has 3, and now it goes to 4. And water is actually losing an H, where NH3 is gaining. So we have an acid and a base here because we have the H+, we have an ion donor, so that would be this one. Our water is donating a hydrogen, it's losing it, and so that would actually be the acid. And then NH3 is accepting, it's accepting the H+, and so that would make it a base. And so that is just another definition of how we can classify acids and bases. And while we're looking at acids and bases, the pH scale is something that is definitely part of acids and bases and will come up. And this is the number that we use to represent the hydrogen ion concentration. So how much hydrogen ion do we have within a solution? And this scale may look familiar. It's on a 0 to 14 scale. If it is less than 7, then it would be considered acidic. 7 is neutral, and anything higher than 7 is basic. Now, some things that we could point out. Your normal stomach acid is right here. So your normal stomach acid is about a 2. hence why people who maybe struggle with ulcers and things, that stomach acid can it definitely hurt the lining of your stomach if you don't have the mucus and things there to protect it. Battery acid is also in there. If you have an upset stomach, then your stomach acid is going to be more at a 1, so it's even more potent. And hydrochloric acid, it can be at a pH of 0, so incredibly dangerous. Things that are very neutral, pure water is at a 7, milk is at a 7, the blood that you have is at a 7 as well. So those are things that are neutral. Things that are basic, baking soda is a base, also like antacids. So if you have an upset stomach, maybe you take Tums or a milk of magnesia. Those are very basic, kind of high in 10s and 11s to kind of combat the really low numbers on the acid side. Bleach, if you ever use bleach on your clothes or anything like that. A lot of detergents, we said soaps and household cleaners, so ammonia, detergents, those are all going to be very, very basic substances. So that's just a little bit about the pH scale and about acids and bases.